Hi gang, Rob here. It is the evening of 14 May 2013. Going to have kind of a short video tonight and part of the Knife School series. Some of you have inquired about my sharpening philosophy and my sharpening methods. And you've heard me talk about edge grinds and the nature of edges on some of my videos. And before you guys start sending me your blades and your money, I thought I'd explain my way of thinking, and believe me, there are as many ways of thinking as there are edge grinds for knives. This is sort of how I see the edge world and why I think it works. So I want to look at sort of two diagrams this evening, and our star of the show will be the outstanding Kershaw Skyline. We're going to use him for a pointer. First chart or diagram I want to look at, and I make no apologies for my lack of artistic skill, is the two types of common bevels or edge bevels put on knives. First, we have the single bevel, where the primary grind of the knife transitions to the edge grind. And we're going to contrast that against what I call the compound bevel, which is primary bevel, and then secondary bevel, or the shiny part you see approaching the edge of the knife, and then the micro bevel. Okay, now let's go back to the left side here, and let's talk about why I don't like the single bevel. A very common final edge grind that you'll see on knives is a 40-degree inclusive angle, and I realize if you put a protractor on the one I drew, it would be more than 40. I did that for the sake of space and being able to see what I'm talking about. Now, if this is your knife, this is your primary grind, the primary shape of the knife, and then it approaches the edge in one angle to the final point, the final knife edge. Now, let's look at what happens. As this knife gets dull, indicated by this dotted line, this point now is missing. To get that knife back to sharp, we have to come to this point. In order to get to that point, keeping that same edge angle, we've got to remove material off this entire sharpened surface from here to here. So my stone is going to be riding over that whole distance. I have to remove material off both sides for that whole stretch to get back to a sharp edge. Okay? Now, let's move over to the compound bevel side and see what happens that's different. In this case, we have a secondary bevel or an approach grind of 30 degrees that stops before it gets to the point, and then we finish with this 40-degree angle. This is exactly what a Spyderco sharp maker does, or would do if it could actually cut metal, which it's not very good at. So we have an approach grind or a secondary bevel of 30 degrees and then 40 degrees at the point. What we have here is a thinner edge grind profile because of that 30-degree angle versus 40. And then we have a little tiny area at the tip, which is much smaller in proportion than this drawing looks, again for the sake of being able to annotate. When this grind goes dull, we have to come to this point to get it sharp. But we only have to remove metal off this much of a run. And let's put that in perspective. Let's lay the old skyline down. That's that far. As opposed to this distance, which you can see is almost the full length of the blade. Which do you think is going to be easier and quicker to put an edge back on? Well, it's obvious. It's the compound bevel. So we've got a thinner knife behind the edge, and we have resharpening or touch-ups that are going to take much less time. And here's the neat part. We can do many of these resharpenings, many of these honings throughout the run of this approach grind before we ever have to touch this 30-degree angle again. So it's thinner, it's able to be touched up easier and many more times, but because this angle is the same as this angle, the knife is just as strong. Okay, that's why, and guys, convex bevels notwithstanding, of course. I'm talking about straight edged edge bevels. The compound bevel works much, much better for long-term use of a working knife than does the single bevel. So that's that, and that's why I do what I do. There are some knives for some applications that are going to be single bevels at a much, much, much smaller angle than 40 degrees. Your Scandi grind knives essentially are single bevel knives at a really, really thin angle. Some guys do cheat a little bit and put micro bevels on them in the interest of durability, and I understand that. Okay, now let's talk about something else that I do. You guys have seen the glaring reflections of my edges on camera. What I don't do is a toothy edge. A toothy edge of micro serrations. If you looked at most factory edges under a magnifying glass or a microscope, that edge that is smooth and one continuous curve actually would look like this. As that knife wears, as it goes dull, those teeth, now we've turned this blade sideways, of course, these teeth, if you section the blade and look at it from the end, start to look like this. Some are bent over this way, some are broken off, some are bent over this way. To get that knife sharp again, and by the way, these teeth are not supported. They're all hanging off into space with no material holding them up except their own selves. That's why they do this instead of just going flat or dull. They bend over, they roll over, they break off. And when I resharpen that knife, I've got a knife that used to be out to here. I've got to take it all the way down to here, travel this whole distance to make it sharp again. And when that knife is in this condition, all it's going to do is rip, tear. So any kind of material that you're cutting that you need a nice clean cut, leave this knife out. About all it's going to be good for is slicing bread. It might be able to rip up a tomato skin, but now when it's sharp and all these teeth are in line, it's going to cut a tomato probably better than this polished edge, because this one's not going to want to pop through the skin as easily as this one will. But very quickly, under any kind of hard use, that's what this toothy edge is going to look like. It won't shave hair. It might grab you, might prick your skin, but it's not going to shave hair. And look how much material we got to then remove to get that back to sharp. Now to sort of compensate or avoid having to remove all this material, there are tools that have been devised to maintain toothy edges, like sharpening steels, which are designed to bend all these teeth back into position, although that doesn't account for the broken off ones. So you're still going to have a grabby blade that snags in areas. Now let's move over to the polished edge. My cutting edge looks like this. One smooth, continuous ribbon of razor sharp steel. Let's look what happens when it goes dull. We've got to zoom in here quite a bit, don't we? Okay, what used to be a point now is a flat or a radius. To get that sharp again, I need to move only down to here. Just a tiny bit of material needs to come off. And you notice I don't have any goofy Burger King crown thing happening either. When this polished edge goes dull, it just changes its point into a radius. I don't have any extraneous material hanging off. I don't have to remove a bunch of broken and bent teeth. And I have this distance to cover to sharpen it rather than this distance to cover. Let's back up here so you can see the difference. Now here's another problem. Let's go back to the toothy edge. What I've done here is sort of tried to give you a representation of what happens, especially with softer steels, when they start out looking like this when you sharpen them and you start running them across those stone. And some of these teeth don't exactly grind off or break off when you run the stone across them. Some of them bend over. And you can, once they start to do that and they start to actually emulate the shape of the sharpening angle that you're using, you're pretty much never going to remove this material. It's just going to sort of bury into itself. And that knife is going to have this nasty, delicate, not strong, rolled edge until you go at it with something really aggressive and take it back to a clean point. There's a lot of knives out there in this world. Guys think they're done sharpening. They think they've removed all that jagged, nasty steel, but it's really just folded over. And if you sort of hold the knife under a light and kind of roll it like this, you'll see that material. You'll see a little line where it's not supposed to be. So, while the toothy edge might be a great tomato slicer when it's brand new, fresh off the sharpener, and not just a tomato, but lots of soft media that have a tougher skin, it's going to perform well for a while, but as soon as those teeth start to look like this, that knife's done, and you got to go a long way to get home to make it sharp again. This polished edge is not going to deform as quickly because you don't see any unsupported teeth. You have one continuous ribbon of steel all supporting itself. Now it'll go dull, but it's going to go dull in a way that looks like this. You're still going to have a good working edge. With the force applied to a blade and the natural taper of that steel, even without a razor sharp point, it's going to cut. Especially in harder media like wood or paper or cardboard. Remember, we're not talking about saws, we're talking about knives. Most of the cutting force of a knife is going in this direction, pushing, not necessarily sawing. This is a great blade profile for a saw. This is a great blade profile for a knife, especially in a micro sense. That's why I take the time I take and use the equipment I use when I sharpen your knives. Don't like toothy, really like polished. Not a big fan of the single bevel. It takes too much work to keep it sharp and you lose too much metal doing it. I really like the compound bevel. Easy to maintain, just as strong, and you conserve the steel on your knife over a much longer time. Hope that helps, guys. That's all we have from Knife School tonight. Remember, guys, sharp is the word. Have a good night.